Hello, this is part 6 and the final part of the GCSE Revision Guide for Higher, which covers probability and statistics. Just a quick reminder, anything with a star next to the question is calculator. So let's just get started. Question number 1. For her lunch, Gina sometimes eats a salad and sometimes drinks a coffee. The probability she eats a salad for lunch on a given day is 0.4. The probability she drinks a coffee on a given day is 0.25. Eating a salad for lunch and drinking a coffee are independent. Complete the following tree diagram. Okay, quick reminder with independence in probability, it just means that one event won't affect the other. Okay, so if she eats a salad for lunch, it really doesn't affect whether she drinks a coffee or doesn't drink a coffee. So one event won't affect the other. And so we can just complete the tree diagram now. Okay. Another quick reminder is that in probability tree diagrams, these all add up to 1. So if you have missing information, you can fill in the other part easily. So this will be 0.6. If we have 0.25 there, one takeaway 0.25 is 0.75. And the same thing is going to happen here, 0.25 and 0.75. And that would be A complete. Part B, calculate the probability that on a given day, Gina does not eat a salad for lunch, but does drink a coffee. Okay, so she does not eat a salad, so this will be this part of the probability tree diagram, but does drink a coffee, and that would be this part of the diagram. Okay, when we get from one event, so event 1, to event 2, you multiply the probabilities. So here we just multiply 0.6 by 0.25, and then once we do that, that would be the final answer complete, and that would be 0.15, and that's finished. Question number 2. A biospinner has 3 sections, each of different color. The table shows a probability that when a spinner is spun once, it will land on blue or orange or on white. A, work out the value of X. So every probability will always add up to 1. So all we need to do here is add all of these. That's in a table. And this will equal 1. So we have 3x plus 0.58 equals 1. Take away the 0.58, so we're solving for x here. So once we take away the 1, we get 0.42. Divide by 3, you get 0.14. That's finished for A. Part B, work out an estimate for the number of times the spinner will land on blue. Okay, well the spinner is spun 250 times, that's for part B. So this is a relative frequency, so you take the number of trials and you multiply it by the probability, and this will estimate how many times you would expect it to happen. So 250 times 0.58, and again, just put that into your calculator, and that will give you a final answer of 145. That's finished. The mean score for all students in both classes are 72.6. The mean score for the students in class A is 75. Work out the mean score for students in class B. Okay, a lot of information here, but it's one of those where you are given 2 groups and it splits the mean between them both, and you have to find the mean based on one group. These questions might seem a lot, but all you need to do is just put the pieces in place and your knowledge of how to work out the mean. So for example, it says there are 28 and 32 students in B. Okay, now the mean for all of them is 72.6. That means if I take class A to be X and class B to be Y, that means if I add their scores, this is their total scores, remember, and divide that by however many there are, so there's 32 and 28, so that would be 60. So if I divide that by 60, I get the mean score of 72.6. Okay, so it's breaking it down one by one like that. What I could do here is times out the 60 to get X plus Y, so 72.6 times by 60, and that will give me 4,356. Okay, just leave that there for a second. It does then say that this mean score for the students in class A, so X, remember we call that X, is 75. Okay, and now remember, how many people are in class A? 28. So times out of 28, and we will get our value for X. And if we do that, we get 2,100. So I can go back to equation 1. Let's call that equation 1. That means 2,100 plus Y over 60 is equal to 72.6. Okay, or I could have gone to this part actually, that probably would have been easier. So that if x is 2100, y would be 4356, take away 2100, and this will be equal to 2256. Okay, so essentially I can just get rid of this now. And what this is saying is that if I add these together and divide by 60, I get the mean of 72.6. But what the question is asking for is work out the mean score for the students in Class B. Class B is Y, so that would be Y over 32, and that's equal to our mean. But we know what Y is now. It's 2256. And this will eventually give our mean, and it's 70.5. Part B, the lowest score in Class A is 39, the range of scores for Class A is 57, the lowest score in Class B is 33, the range of scores for Class B is 60. Find the range of scores for all the students in both classes. So we need to work out the range, or it's given us the range, we need to work out the highest score for each. So let's just focus on A for a second. Remember, the range is the largest, take away the smallest. So that means we need to work out what this could be then, the largest. So the largest number I could say is x, take away 39, equals 57. So that means x must be 96. Do the same for this one. We have the lowest score. No, not the lowest score. We already know what the lowest score is. It's 33. It's the largest score, which is y. Take away 33 equals 60. So y must be 93. Okay, so if I just do a quick number line, our lowest, which is our lowest here, we have A is 39 and B is 33, so that's our lowest. Our largest number is 96, and that's A. Okay, so remember the range, again, is the largest, take away smallest, so that would be the range. So all we have to do here is do 96, take away 33, and this will be our final answer, 63. Question number 4, this is a time series graph, and to be honest, I don't really see this come up too much, but it is part of the syllabus, so I've still put it on. So a time series graph just measures data across a certain period of time, and this could be usually sales, for example, over a given time period, and that's basically how a time series graph works. Right down to things that are wrong or could be misleading with the graph. Well, firstly, for example here, you can see in the diagram these are like curved lines, which shouldn't happen. We should be using straight lines. So we should be using straight lines. That's one example that's wrong with this. So straight lines, not curved, not curved. Okay, part 2. Now, we do split it into quarters, but as you can see, we go from 2, 3, and 4, which means that 1 is missing. Okay, which means first quarter, or in this case, 1 is missing. And that's really all there is to this question. Question number 5, the stem and leaf diagram gives information about the numbers of tomatoes on 31 tomato plants. Work out the median and interquartile range. Quick reminder here, these keys are very important. It might ask you to fill it in. And as you can see here, 5-7 equals 57. So for example, if I was to use this number and this number, that would be 32. Now we want the median and interquartile range. Right, median. Right, so what I would recommend here is, because we have an odd amount of numbers, or tomato plants in this case, so what I want to do here is make it even so I can work out the median very easily. And what we can do here is we do n plus 1 divided by 2. This is a way to work out the median. So that'd be 32 divided by 2, which is 16. But this is the position, not the actual median. So I need to go 16 in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that'll be 32. Interquartile range. Again, just very quick summation of interquartile range. So if we have some data here, it's the middle part of the data. Okay, so this would be the minimum, this would be the maximum, this would be the lower quartile, this would be the upper quartile. Okay, and the interquartile range is all this part of the data. So upper quartile take away lower quartile. So upper quartile take away lower quartile. And just like median, we can work out these. So upper quartile is, because it's the 3/4 in, it's going to be 3/4 of, or 3 times the lower quartile. Now, it's probably better to do the lower quartile first. So the way we could do this is n plus 1 over 4. Okay, so this will give me that an even number, 32 divided by 4, which is 8th position. Right, so the 8th position is going to be 21. For the upper quartile, it's just 3 times n plus 1 over 4. And as you can see, we'll get 3/4 because it's 3/4 into the data zone. So if it's 3 times 8, which is 24, so it's a 24th position. Okay, so as we know, the 8th position is 21, which is this bit. So we just want to go into the 24th position. So, okay, so that's 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So it's going to be 45. And we have the upper quartile as 45, take away 21, and this will give us our interquartile range, which is 24. And that's finished. Question number 6, we have a box plot diagram. The table shows information about the math scores of students in Class A. Draw a box plot for this information. So it's going to be, we can see here the minimum is 9. So I'm just going to draw a line that goes onto 9. I'm going to just zoom in a bit actually. Okay, so just move this first. Okay, so I'm going to draw a line at 9. Use a ruler. Please use a ruler. Don't use freehand. So that'd be 9 at that point. Lower quartile is 15. That'd be 15 there. Median is 19. That's this point there. Upper quartile is 31. And maximum is 43. And you draw a box around the quartiles. So then if I just draw a box around it, so it looks like this, and then link it with the minimum and maximum, make sure the lines do not go through, otherwise you will lose a mark. And that's finished. It's very, very simple. The box plot below shows the distribution of the math scores of students in Class B. Compare the distribution of the math scores of students in Class A and Class B. Okay. What I'm going to do here is I'm just going to jump ahead and give you the answer, but then I'm going to go through why I've done what I've done. Okay, so I've written out the reasons that would be valid to get 2 marks. So part 1, the median for Class B, which is 21, is higher than Class A, which is 19. So therefore, on average, let's highlight the keyword there, Class B did better. Okay, part 2, the range for Class A, which is 34, is higher than the range for Class B, which is 33. Therefore, Class A's score is more spread out. Okay, so I'm just going to quickly just go through what each of these means. When you do comparisons between 2 box plots, what I'd highly recommend is measure 2 things. You want to measure an average. So average would be mean or median, but we can't do mean here, so median would be the way to go. So measure one average and measure one part of spread of data. Okay, spread of data, we can use range or you can use interquartile range. Either is fine. But what range does is it measures the consistency of data or how spread out data is. So for example, if we have a data that's a range like this compared to a range that's smaller, because these scores are more closer together for this one, we would say that this is more consistent than the left-hand side. Or if you look at it from the point of view from the left-hand side has data that is more spread out, which is what I put for part 2. So always do an average and a spread of data and you will get those 4 marks. Question number 7, we have a Venn diagram here, but we are also using Venn diagram notation. Part A, it wants us to find n, I'm just going to rewrite it here, of A, U, C. I do need to remind us here that this n on the outside, just in case you don't know what that means, n means the number of elements. So really pay attention to what's outside the brackets here. So number of elements. So what we mean by that is, for example, for B, we can see there's 2 numbers. So the number of elements for B, so if I was to say NB, this would be 2 because we have 3 and 6, which is 2 numbers, so 2 elements. So that's why that would be 2. Okay, now this is saying A union of C. So union means everything in A and C. Now everything in A and C is 2, 4, 7, 3. So there are 4 elements. Okay, that's part I done. Now part 2, this is N, and then you've got B and apostrophe. So this means complement of B. Now what that means is everything not in B. So not in B. So what's not in B? We have 2, 4, 7, and 10. So again, that is going to be 4 elements. So I would put this is equal to 4. Okay, part 3. Now, if you do struggle with these questions where it starts to mix and match like different types, what I'd recommend is just list out what's in each. So for example, A, what do we have in A? We have 2 and 4. What do we have in not C? Not C would be 2, 6, and 10. Now this sign here means intersection. Now intersection is what they have in common. So if we have 2 Venn diagrams here, this will be the intersection point, what they have in common. Now what they have in common is they both have a 2. And then as we're looking for the number of elements, this would mean it will be equal to 1. Lastly, part 4, N, complement of U, union complement of C. I'm going to list out not B first, all the numbers in not B. That's going to be 2, 4, 7, 10. Okay, that's everything in not B. And not C, this is equal to 2, 6, 10. Okay, so we're looking for the union that comes up for both. Okay, a lot of people get confused. They'll think, okay, if it's not B, then we cannot use numbers in that's not B. Then the answer cannot contain numbers that are in B. Okay, but actually, that's not actually true. That's not what the question is asking. It's asking the union of numbers that are in not B and what's in not C. Okay, so in other words, if I was to do another Venn diagram, and I did not B and not C, so for example, we have 2, that's the intersection point, and 10. Not B has an exclusive 4 and 7, and not C has 2, and 6, just 6. Okay. Now we consider union is everything in here. Okay, so that's going to be 4, 7, 2, 10, and 6. Or in other words, what you could do is I could just get all these numbers at the top, ignore any duplicate numbers, so that'll just be 6 there. And you can see that correlates with the Venn diagram we've just drawn. So the number of elements for this will be 1, 2, 3, 4, 5. Okay, so that'll be our final answer. This will be 5. Okay. And just to reiterate what I was saying, a lot of people get confused because they think, well, if it's not C, okay, how are we able to include the number 4, for example? But again, that's not what the question is asking. It's just basically asking, list out all the data that the question has said, and what is everything, what is all the data that comes up? That's what we want. Okay, so don't get put off by compliments. Question number 8, calculator question. The group frequency table gives information about the heights of 30 students. Work out estimate for the mean. So the reason why it's saying estimate is because, for example, if I go in this row here, there is 7 students that have a height between 140 and 150. But it's classified in groups data. In other words, we don't know the exact height per student. So how do you work out a mean for this? Well, the fairest way we can do this is use midpoints. So the midpoint between 130 and 140 would be 135. And I'm just going to write down a midpoint for all of these. And I'll explain in a second what we do. Once you have all the midpoints, we times by the frequency. So in other words, we are estimating that 7 students have a height of 145. So what would the total height be in that row? And you would just use your calculator and multiply by all of these. So this is going to be 135, 1015, 1240. The last 2 we have 1650, and then the last one is 700. And what we're going to do is we're going to total these. Okay, if we total these, we get 4,740. And then we divide this number, because this is basically the total height for everyone, and we divide by the number of students, and we divide by 30 students. A common mistake is people divide by the number of rows. Make sure you do not do that. You divide by the total amount of, in this case, students. So we're going to do 4740 divided by 30, which is 158. So that'll be that one finished. That's 158. Write down a modal class interval. So modal means most common. So which row is the most common? So in this case, like how many students make up the most? And that would be this one here. So most common will be this interval. And make sure you write the interval, not 10, the interval, otherwise you lose a mark. Part C, find a class interval which contains the median. Okay. Now, median, remember, again, is just the midpoint or the middle. Now, how many students are there? 30. Now, this is an even number. I don't need to do this, n plus 1 divided by 2. I don't need to do that. Although you could if you wanted to. But it's easier just to get an even number divided by 2, because this will give us our position. So I know that this is where the median lies. It's a 15th position. Now, if it's a 15th position, what you want to do is use cumulative frequency and then find or pinpoint where 15 will be. So we have one student here. If I go along, I'm going to get 8 there. If I go along again, I'm going to get 16 there. I'm just going to stop there for a second, because going up to this point is 8 in. That means if I get up to this point, that's 16 in. But I know that median lies in a 15th position, so it would lie around there, for example. That means our interval for the median is 1,5. So H is more than 1,5, but less than or equal to 160. That would be our answer for part C. Okay. Lastly, part D, we have a incorrect frequency polygon has been drawn from the information table. Write down 2 things wrong with this frequency polygon. Right. What I want to do, first of all, is I want to look at the table. Okay. Because I want to see how this data points they've done. So they've done 130. Well, all I need to do is really look at that 130, and I can tell why that's wrong. Okay. But actually, I'm also going to look at the second data point, which is this one, which is 140. All right, I can see what's wrong. When you do frequency polygon, you use the midpoints. And clearly, they've used the lower bound, because they're doing 130 and 140, which is wrong. So that would be one thing that's wrong with this one, is they have used midpoint. They should have used midpoints. Should use midpoints. Okay, part 2 is in a frequency polygon. I'll show you what this should really look like shape-wise. Or no, I'll give you an example of what a frequency polygon should look like. It could look like something like that. Okay, notice the difference between the left and the right is I did not join these two data points, because you're not supposed to do that. Okay, so if I say that's A and this is B, and then what I can say here is A and B do not join. That's finished. Number 9, there are 16 sweets in a bowl. 4 of the sweets are blackcurrant, 5 of the sweets are lemon, 7 of the sweets are orange. Anna, Ravi, and Sam each take at random 1 sweet from the bowl. Work out the probability that 5 lemon sweets are still in the bowl. This is conditional probability. And the reason for this is because if we take a sweet and we do not put it back, what happens is there is 1 less the next time we pick a sweet. So if I was to do a probability tree diagram, you can see there's 3 different types of sweets. So 1, 2, 3. That would be B, L, and O. For example, if I pick a blackcurrant, I can pick another blackcurrant again, but the probability will go down. So blackcurrant is going to be 4 out of 16. Now, if I pick a blackcurrant again, there's 1 less sweet in total, but there's also 1 less blackcurrant, so it'll be 3 out of 15. Now, you could do a tree diagram like this. That would be perfectly valid. But because we're only really interested in 5 lemon sweets, You can look at it from a point of view where the 5 lemon sweets has its own branch and all others which we can combine. So this will be, I could say this is lemon and this is not lemon. Okay, you actually don't have to do a tree diagram for this, but I think this might be helpful here. So if I pick a lemon, there's only two options I can do again. So lemon and not lemon. If I pick a not lemon first, that could be lemon and not lemon again. Okay, so I was going to put here lemon first. We know that there are 5 out of 16 lemon. Not lemon will be the 7 and 4, which is 11. Yep, 7 and 4, which is 11, so that's 11 out of 16. Okay, so if I pick a lemon first, I know that's 5 out of 16. If I pick a lemon again, remember this event 1 is event 2. I know there's one less lemon because I picked one previously, and there's one less total, so 15. Okay, in terms of not lemon, you know what, I'm just going to put all over 15 because I know that if I take one before, there's going to be one less. There's a maximum of not L left still. So this will be 11. Okay. Now, if I start again and go to not lemon, I know that there are 11 out of 16. At this point, it's a maximum amount of lemons, so that'll be 5, and this will be 10. Okay, that's my tree diagram complete. Now, what it's saying is work out the probability that 5 lemons are still left in the bowl. So really, all I really care about is where we don't pick a lemon at all, which would be this root and this root. And if you remember from the first question, to get from one branch to the other, we use a multiplication. Or in other words, we use the AND rule, what we call the AND rule. And this is a calculator question. Okay. Work out probability that 5 lemons are still in the bowl. Well, I've just realised actually there's 3 people. So I should have done this. Okay. But if you remember moments ago, I said you don't have to do a tree diagram. And you really don't, because all I need to do here, or I could just go onto this branch really, you don't need to complete this tree diagram. If I take another non-lemon, there'll be 9 out of 14. And this is really the branch that I want. Okay, so that will be times 9 over 14. So I just need to go rid of this equals. Completely forgot there were 3 people. There was only 2, but there's 9 out of 14. So just put that into your calculator and you get 33 out of 112. And that's finished. Question number 10. A total of 80 men and women took part in a race. The cumulative frequency graph gives information about the times and minutes they took for the race. Part A. Use the graph to find an estimate for the interquartile range in minutes. We've done interquartile range a few times now, but just to recap again, it's upper quartile, take away lower quartile. Now, the upper quartile is 3/4 along the data point, and it finishes at 80. So half would be 40. If I add another quarter, it will be 60. So this will be my upper quartile. So what I'm going to do is I'm going to draw a line across from 60 and then go down. Again, use your ruler, please. The lines are a bit thick here, but that's roughly, let's see, that's roughly, I'd say that's 56 at that point. Okay, so that's going to be 56 at that point. Then I'm going to work at the lower quartile, which is a quarter along, so that's going to be 20. So I'm going to go from 20 and then go along there. Again, the lines are a bit thick, but I'm just going to do the best I can here. So that's going to be 38, I think. So it's going to be 56, take away 38. And that'll be our interquartile range, which is 18. Okay. So that's part A done. Part B, 60% of the men took 50 minutes or less for the race. No women took 50 minutes or less for the race. Work out an estimate for the number of men who took part in the race. So 60% of the men took 50 minutes or less for the race. Okay, so everyone who took 50 minutes or less were men. So what I want to do is go from 50. Again, you can just use a ruler. I'm just going to just use a marking, and that will go there. And as you can see, this is 42. Essentially what this is saying is if that part is 42, this is saying that's 6. So it's saying 60% is worth 42. Okay. So just to reiterate, 60% of the men took 15 minutes or less for the race. Okay, so 42 to 80. Sorry, start that again. At this point, it's 42, and it's essentially saying that at this point here, okay, this part of the graph, which is from 0 to 42. So that's 60%. So 60% must be equal to 42. It's a bit of a percentage part here. And then what we want to do is work out 100% or the original amount. We could work out 1%. Divide by 60 both sides. If I divide by 60 both sides, I get 0.7. Then 100%, I just times it by 100. To get from there, I need to times by 100. Whenever I do one side, I do it to the other. That's going to be 70. So the answer would be 70. Question 11. We have a histogram question here. The histogram gives information about the weight in grams of some oranges in a box. 24 of these oranges weigh less than 20 grams. Okay. The medium oranges weigh between 35 and 55 grams. I'm just going to just section that in actually. Just going to zoom in a little bit. So we have 35 grams. So 1, 2, 3, 4. So there, and 55, which is there. Work out estimates for the number of medium oranges in a box. So in a histogram, remember the frequency. Just going to write it here. The frequency is the area underneath the graph. Okay. And if I want to work out frequency density, I'm just going to call that FD. This is frequency divided by class width. Okay. You need to know these. It's very important for histograms. It's very basic information for histograms. If you don't know this, you're going to... I don't really know how you're going to do it. Okay. So work out estimate for the number of medium oranges in a box. So what we want, I'm just going to section off. We want to go the area between these 2 points. That's what we want, because remember, that's a frequency. But the only problem with that is we don't know the frequency density, because if we knew the frequency density, we could work out the area. So that's our missing information. So the plan is to work out the frequency density at this point and at this point. Okay, now we can do this because of the first line. It says 24 of these oranges weigh less than 20 grams. So this is this part here. Now what this is saying is that this has a frequency of 24. And to work out frequency density, it's frequency 24 divided by class width, which is 20. So 24 divided by 20, and this is a calculator paper, so this would be 1.2. Okay, so at this point it's 1.2. Now what we want to do is just see, well, it looks very clear to me that this must be 1 there. And every little box, every little tiny little box is going to be 0.1. Okay, that means if I go to here, this must be 2. And every little box is 0.1. So this will be, what, you know what, I'm just going to draw the boxes there. So this is box 1. And we know that this must be 2.2. And we know the class width is between 35 and 50, so that's 15. Let's do box 2 as well, so there's a slightly smaller box. Class width is 5. And the height is at this point here, which is 1.8. And all we do then is just times these together, because this will be our area, because as you can see, it's essentially a rectangle. 2.2 times 15, add 1.8 times 5. And when you do that, we get 33, and 1.8 times 5 is 9. So this now becomes 42. And that's our final answer for that question. Question number 12. A scientist wants to estimate the number of fish in a lake. He catches 50 fish from the lake and marks them with a die. The fish are then returned to the lake. The next day, the scientist catches another 80 fish. 4 of these fish are marked with a die. Work out an estimate for the total number of fish in a lake. It's quite wordy, this question is, but they're actually very, very simple. This topic is what we call capture recapture. Okay. So what you want to do with this one is you want to just focus on one event first and focus on the second event after. So what it's saying is that he catches 50 from the lake, but there's 50 out of a total population of X amount, which we don't know. Then the next day he catches 4 out of 80. And it's just basically equivalent fractions. Or you can just solve for x here. So I'm going to times out the x, so 50 equals 4x over 80. Times out the 80, that's going to be 4,000, equals 4x. Divide by 4, so x will be 1,000. Okay, so this is our estimated population of the lake. And that's finished. Question 13. There are 17 marbles in a bag, which are each different. 2 of the marbles are to be chosen to make a pair. Ben thinks the number of different pairs that can be chosen is 136. Mark thinks the number of different pairs that can be chosen is 272. Who is correct, Ben or Mark? You must show your working. Okay, this topic is called product rule of counting. Or you can think of it as combinations. It does require a little bit of logic, these types of questions. But essentially what's happening is we're talking about combinations here because we talk about different pairs. He's saying there's 17 marbles in a bag, so there's 17 in the bag here. Okay, so if there's 17 in the bag, if one is to be picked, then there's only 16 left. So that'd be times 16. So we would do 17 times 16, and this will give us the total number of ways that we could pick a pair of marbles. Okay, so if I was to do 17 times 6, this is a calculator question, I get 272. Now, this is Mark's answer. Now, is this correct? And the reason, well, what the answer is actually no, it's not correct. And I'll just give you a very, very quick reason why. Imagine we had 2 counters, a purple and a red counter. Okay. Let's say if we were to pick a counter from a bag, we got a purple and red, which is actually what we wanted. But in this scenario, you can see that purple has been picked once, and then we will go again. The second counter is red. Okay, that's great. We got a purple and red, which is what we want. But what if it was the other way around? What if I picked red first, and then we picked purple? Does it really matter the order that I picked it in? What matters is the outcome. So this tells us there's one combination. But there's 2 different ways to get that combination. But the result is the same. That's all that matters. So as you can see, there are 2 ways, but there's one combination. So essentially, how could I answer this? I could just say 2 divided by 1, and this will give me the combination that I want. The same thing happens here. Okay. Now, just again, it's saying that Ben thinks a number of different pairs that can be chosen is 136. Okay. Now, Ben is right, because just like I did there, what we would have to do is do 272 divided by 2, because it doesn't matter the order of the way we pick the models. What really matters is the outcome. Okay, so we're going to do 272 divided by 2, which is 136. So Ben is right. That's finished. Question number 14. This is the very last question of the revision guide. Question 14. A bag contains only 10 cents and 20 cent coins. Joseph takes a coin from the bag, record its value, and replaces it in the bag. So it's not conditional. He does put it back in. All right, so I'm just going to put there replaced. He then takes at random a second coin from the bag, records its value, then puts it back in. Joseph finds the mean value of the 2 coins. To be honest, I don't know if I'm pronouncing his name right. But anyway, the probability that the 2 coins have a mean of value of 10 cents is 49 over 121. Okay. Work out the probability that the 2 coins have a mean value of 15 cents. Okay, so quite a bit of information here. So what's happening is the probability of 2 coins, or well, the mean value of 2 coins is 49 over 121. Right, just one thing here. If it says a mean value of 10 cents, so we only have 10 and 20. Okay, so we only have 20 and 10. These are our 2 coins. Okay, now if we want a mean value of 10, and he's picking 2. The only way that you can get that is by picking two 10-cent coins, because 10 and 10 over 2 would be 20. Oh, sorry, not 20, of course, 10. Okay. So we can't get that with 20 because you're always picking 2 coins. So if I did 20 at 20, that'd be 40 divided by 2, which is 20, which doesn't make sense. Or if I did 20 at 10, that would be 30 divided by 2, which is 15. So this must mean the 49 over 121 must be 2 10-cent coins. That means that if you were to do a probability tree diagram, we would need to do one event, which is 1 10 cents, times the other 10 cents to get 49 over 121. So probability of 10 cents times probability of 10 cents equals 49 over 121. In other words, we could square root this because these are the same. So if I square root 49 over 121, I get 7 over 11. Okay. So probability of 1 10-cent coin is 7 over 11. Okay. So work out the probability that the 2 coins have a mean value of 15. Now, I did mention it earlier, the way we can get that is 20 at 10. So mean of 15 cents would be 20 at 10 divided by 2, which is 15. Okay, so in other words, we want to pick 20 and 10. Okay, but there are 2 ways that we can get this. We can either get probability, we can pick 20 first, and then multiply that by probability of 10. That's one way we can get it. Or we can do probability of 10 times probability of 20 cents. That will give us a mean value of 15. So we are looking for these probabilities. So the probability of getting 20, well, if the probability, I'm going to write the probabilities on the top here. I should have done this earlier, actually. I've done it for 10 cents. So 10 cents equals 7 over 11. Probability of 20 cents is therefore 4 out of 11, because remember, this has to add up to 1. So probability of 20 is 4 out of 11 times probability of 10, which is 7 out of 11, which is 28 over 121. And again, if I go on to part 2, probability of getting 10 cents is 7 over 11, and probability of getting 20 cents, remember, the coins are replaced, so the total count does not go down. That's also 28 over 121. Okay. So do remember there are 2 ways in which we can get 20 and 10, not just one way. And then, if you remember the OR rule, we always add. Okay, because there's 2 different routes, so that we would add these probabilities together. And if we did that, we get 56 over 121. And that is the final question done for all the revision guides. I hope that was helpful, whichever year you're doing the exam. And I wish you best of luck for your upcoming exams. Okay, goodbye.